Now, an agonist is a drug that binds to a receptor, or a ligand is a drug that binds to a receptor and activates the receptor to produce a cellular or biological response, or it is a molecule which mimics the effects of an endogenous ligand or a neurotransmitter. If adrenaline is your ligand here, it will bind to its receptor and will activate the pathway exactly in the same fashion as shown here. I repeat, the adrenaline will stimulate the receptor, which is the beta receptor, both beta 1 and beta 2. Beta 1, as you know, is present in the heart. Beta 2 is present in the lungs. It will activate the cytosolic cyclic AMP. After that, pKa, a protein kinase A in the cytosol, will be activated. That will eventually lead to the biological response, which is tachycardia and bronchodilation. Now let's explain the second part of the definition, which says it is a molecule, or agonist is a molecule which mimics the effects of an endogenous ligand or a neurotransmitter. So as we know that catecholamines such as adrenaline and noradrenaline act as endogenous neurotransmitters. So if you give someone an adrenaline injection in survival situations such as anaphylactic shock, it will mimic or act like their endogenous neurotransmitters and will increase the heart rate and dilate the bronchioles and save the person. So let me briefly introduce the term antagonist here. Antagonists are the drugs which will block the binding of an agonist to the receptor and will counteract the effects of agonist. We shall cover this concept later on in another video. So interestingly, you might also know that the man who plays the leading role in a movie or a fiction is called agonist. Interesting. Yes, they also call it protagonist, commonly called as the hero of the film. Now, if in a film the hero was clearly going on to win, it would not be much of a story. So they add antagonist to the story. The antagonist is the character who wants to keep the protagonist or agonist away from reaching their goal. The antagonist crafts those complex schemes to outsmart the agonist. Well, the agonist sometimes is shown to have such nonsensical and ridiculous, impractical moves where he sometimes outsmarts the death. Well, that's where the story starts looking stupid. I'm sorry. Let's get back to the topic, as I'm afraid we are drifting away from the topic. So let's quickly see how an agonist activates a receptor. This is our receptor. This is the agonist. Forms agonist receptor complex. Leads to the activation of receptor. So this red is the active receptor, and it gives a biological response. Or we may show this as the agonist binds to the receptor, binding step, forms agonist receptor complex, leads to the activation of the receptor. The star represents the active receptor and produces a biological response or a pharmacological effect and displays some efficacy. Now, all that we have seen in this slide is according to the classical receptor theory. However, according to modern receptor theories, an agonist could have more than one active state. So this is one active state according to the classical theory. The modern theory says that it could be more than one or multiple active states, and multiple active states would then lead to multiple responses and thus multiple efficacies. So an agonist, according to modern theory, have multiple responses, or it activates multiple cascades inside the cell and thus have multiple effects. We shall cover this concept later on in another video. Now let's see that animation once more.